Hello, my name is Alexis Sutton, and I'm here with Daniela and Trevor, and we're going to be talking to you about the Formula One engine, which we disassembled, measured, and then modeled in CATIA. Here's the overall assembly ended up looking like. Up first is the camshaft timing piece. The workbenches used in this were something we actually didn't talk about in class, which was sketch tracer and part design, and then once the design was sketched and measured, it was then extruded. Next, we have the intake and outtake valves, which were actually identical except just with different dimensions, and all that was used was part design. So we have the lowercase, definitely one of the more complicated parts. Here we used part design and generative shape design. Overall, this took about 4 memos to complete, so it kind of slowed down the rest of the process. We have the piston. This was a 4-cylinder engine, so there are 4 total, and all that was used was part design. Next, with head gasket, again, we had to use the tray sketcher for this and then part design. This definitely had some interesting geometry, so I had to be very careful when I was extruding this, but at the end it actually matched up almost perfectly, so that's the most you can ask from this kind of part. Then we have the crankshaft, and the workbench is used here for part design. Definitely the most complicated part of this was the gears and measuring the different cranks. I'll give it a little point. So it was very hard to measure them. So I wouldn't be surprised if some of the measurements were off, but I tried to do what I could to get the correct measurements there. There's the timing chain, link, and pin. And these are two different parts that were assembled down here. So these were just 2 simple parts in part design, and then the hardest part was getting them in kinematics. And due to time constraints of the project, this didn't actually end up making it into the final project. And then the last part I did was the uppercase, which is another very complicated part which included part design and GST. And if you see here, this looks very similar to the head gasket, and that's because it actually was copied, the sketch was copied and pasted right here in order to make sure that everything matched up perfectly.
This is Kayla speaking now, and I'll be discussing the parts that I did for this project. The first one was the cam hold that you can see here, and the main workbenches I used were GSD and then part design. So what I really did in GSD was sort of this curved section right here. I used point to line, or point to point, and then point direction. Used planes to model it, and then same for these little curved parts. And after I got the general shape of that, I did a sweep for this section right here, and then the fill for this. After that, I went into part design and oh my goodness, and used the thicken tool. And then from there, the rest of this left section was modeled in part design, again using planes, symmetry, and then rectangular pattern in order to get the exact replica on this side. And then again, just different planes for this section because I didn't want these repeated over here since that's not what that part looked like. But yeah, that was the main thing here. We have gears 1 and 2. Now, these were relatively simple parts, although this first one took me a couple of hours just because I couldn't get the part to actually extrude, just because it kept saying there was discontinuity. So after many videos on YouTube, I was able to figure out that the main problem was that first I had to do this disc part and then do one of these and then sort of draw an axis and then have a circular pattern tool in order to rotate this. And after figuring this one out, this one was a lot simpler to figure out from here, with the main differences being these geometries right here. But again, really pretty straightforward. Next one is the half ring, and again, this no GSD was used here, just part design. I started by, I believe, sketching this section, just sort of this profile right here, and then using the shaft command to get this half like semicircle. From there, I used a plane to get this hole, and then circular patterned it. Another plane up here to sort of get this sort of triangle geometry, extruded that, and then I did a pocket for this section right here. So again, this part wasn't too challenging, very straightforward. For sort of subassembly to this part, since the rod goes through here and the gear goes, I believe, down here. So all these parts were very straightforward, part design, just sort of circle and sketch and then extrude. Same here. And honestly, same here, although this hole here is threaded. I believe I chose M thick pitch, like probably M6 or something like that. I don't remember. But yeah, overall. And then this was plaquette 2. And then the main thing here was I had to use a plane here and pocket this section since this little hole was on the outside tangent to this surface. Next we have the camshaft head connector. I could have done this part in GSD, but sort of decided to do all of this in part design. So how I modeled this, I started with just this left half. I did this part, extruded it, and then sketched this interesting shape up here, extruded that, did these little sections, and then part of this, and then just reflected it to get this, since it was a symmetrical part. And next, we'll be discussing his section.
Hello, this is Trevor. I'm discussing this portion. I'm discussing the camshaft. On the camshaft, what I did was I did it in part design, and what I had to do was I wasn't able to revolve the camshaft itself because I had to create each cam itself on a different axis. So to do that, I padded the original circle at the front end here, right here, and then from there I measured each step out and then just padded it again. And when I got to the individual cams, I offset them by 90 degrees each time. The next part was the intake and exhaust valves, as you can see right here, and the piston ring right here. For the intake and exhaust valves, what I did is I created half of the profile and then just revolved it around. That was relatively easy because I got all the dimensions on there and just revolved around and ended up looking pretty nice. And with the piston ring, I just created a semicircle with a cut in it and then padded. The next part was the head. This was actually a very difficult piece. What I needed, or what was very hard about it, was getting all the inner dimensions. I really had to simplify this down just to make time for the project. What probably would have been a better idea to do was do it in the GSD and get all the actual profiles and sections correct. Next was the intake and exhaust or the intake inner and outer springs and the exhaust springs. So what I did for these is I put them into GSD and used the revolve command in GSD, and then just closed the surface and used planes to cut the springs so they were flat on the top and the bottom. Next was the connecting rod. The connecting rod geometry was actually very hard to do. I used some slot commands, some hole commands, and some chamfer commands to get the curves on the edges. And then also there's the intake and exhaust valve keeper and the connecting rod bottom were all made in part design. For the keepers, I once again used the revolve command in the part design to create the profile of them, and that was very nice, and they came out looking almost the same as the actual keepers. And then for the connecting rod bottom here, I used the pad command and then also hole commands and all that to create that.